I will make this topic very easy. Click the subscribe button below and watch this lecture until the end. Empirical formula and molecular formula. What's empirical formula? What's molecular formula? I'll give you the answer of these two questions. Empirical formula is the simplest form of a compound. It does not tell us the exact number of atoms present in a compound. The subscript of each atom in empirical formula is in simple whole number ratio. Now molecular formula, the actual formula of a compound, shows the exact number of atoms present in a given compound. Let us take glucose. In glucose we have 6 carbon atom, 12 hydrogen atom, and 6 oxygen atom. Therefore, this glucose is the actual formula of glucose. And again, it's molecular formula of glucose. Now, let us divide each subscript of glucose by 6. 6 upon 6. We have C, only C. 12 upon 6, we have H2. And 6 upon 6, we have only oxygen. Therefore, its empirical formula is CH2O. Now let me give you different example of empirical formula and molecular formula. Phosphorus pentoxide is empirical formula. When we multiply each subscript of phosphorus and oxygen by 2, it changes into molecular formula. 2 by 2, 4. 5 by 2, 10. Therefore, P4O10 is molecular formula. But P2O5 is empirical formula. CH is empirical formula of benzene. And now let us multiply each subscript of hydrogen and carbon by 6, and it became molecular formula of benzene. C6H6 is the molecular formula of benzene. Determine the empirical formula. We have 3 steps to determine empirical formula. The first steps, given atoms. The second steps, number of moles. The last step is simple ratio. Now let me give you example. Find the empirical formula of a compound that contains 43.6 phosphorus and 56.4 gram oxygen. The first step is given atoms. The given atom here is phosphorus and oxygen. Atomic mass of phosphorus is 31 gram and that of oxygen is 60 gram. Now come to the second step. The second step is the number of moles. Number of moles is equal to given mass over molar mass. So the mole of phosphorus is equal to given mass over molar mass. The given mass of phosphorus is 43.6 upon 31 gram per mole, which is equal to 1.41 mole. And oxygen, the given mass of oxygen is 56.4 gram, and its atomic mass is 16 gram per mole, and its mole is 3.53 mole. Now the last step, simple ratio. To do so, let us divide each mole by smallest mole. The smallest mole here is 1.41. 1.41 upon 1.41 is equal to 1. And 3.53 upon 1.41, which is equal to 2.5 mole. Now, the subscript of phosphorus is equal to 1. The subscript of oxygen is equal to 2.5. But subscript will never be fraction number. So let us change the fraction number into simple one number. To do so, let us multiply each subscript by 2. 1 into 2, which is equal to 2. 2.5 into 2, which is equal to 5. Therefore, The empirical formula of this compound is P2O5. This is the empirical formula of this compound. Now molecular formula equal to N times empirical formula. Now let me give you a different example for this one. A compound contains 24.27% carbon, 4.07 hydrogen, and 71.65% chlorine. Its molar mass is 98.96%. Find both empirical formula and molecular formula. The first step, given atoms carbon, hydrogen, and chlorine. Atomic mass of carbon is 12, atomic mass of hydrogen 1 gram, and chlorine is 35.5 gram. The second step, number of moles. Number of moles of carbon is equal to 24.27 gram upon 12 gram per mole, which is equal to 2.02 mole. That of hydrogen, number of mole of hydrogen is equal to 4.07 gram upon 1 gram per mole, which is equal to 0.07 mole. And the chlorine, the given mass is 71.65 upon 35.5 gram per mole, which is equal to 2.02 mole. The third step, the simplest ratio. Now, the simplest number mole here is 0.02. Let us divide each mole by 0.02 mole. 0.02 upon 0.02, which is equal to 1. 4.07 upon 0.02, which is equal to 2. And finally, 0.4 chlorine, 0.02 upon 0.02, which is equal to 1. Therefore, the subscript of carbon is 1, the subscript of hydrogen is 2, the subscript of chlorine is 1. And empirical formula of this compound is CH2Cl. This is the empirical formula of this compound. Now let us determine molecular formula. Molecular formula of this compound is called N times empirical formula. We know N is equal to molar mass of molecular formulas over molar mass of empirical formula. Molar mass of molecular formula is given, but molar mass of empirical formula is unknown. We must determine the molar mass of the empirical formula. The molar mass of the compound is 98.96. Molar mass of the empirical formula of the compound is 49.5 gram. So N is equal to 98.96 upon 49.5 gram. N is equal to 2. Now, molecular formula is equal to N times empirical formula. Empirical formula here is CH2Cl. Now, molecular formula is equal to C2H4Cl2. Thank you.